Okay, here we have a calculator-intensive rate-in, rate-out problem. And these are becoming sort of ubiquitous on the AP exam. You should expect to see a rate-in, rate-out problem. And you need to document your optimization work very clearly. That's going to be C in this problem. So let's go through this. First of all, we have water flowing into a drain pipe, and they give us the model for inflow of water is R. And they're telling us time is in hours on 0 to 8. And the pipe is partially blocked, so the water is draining out at the other end by a different model here. Also on the interval from 0 to 8, and we're told that there are 30 cubic feet of water already in the pipe when time starts. So problem A says, how many cubic feet of rainwater flow into the pipe on the initial 8-hour time interval? That is a straightforward integration problem. You need to integrate your R of t function. So we're going to do that on our calculator. I'm going to clear out my prior problem here. And then I'm going to put in R, which is 20 times sine of t squared divided by 35. And then since I'm integrating, I'm going to go to F3, choice 2, integrate, grab my function, integrate with respect to t on the time interval from 0 to 8. So on this problem, you're scored. You just get a point for the setting up the integral, knowing that you have to just integrate R, and then you get a point for the answer, which is 76.570. And you're allowed to just write 57 and not put the 0 in. If your third decimal place is a 0, they don't require that decimal place to be written. Oops, sorry. Okay, part B, they want to know is the amount of water in the pipe increasing or decreasing at 3 hours. So basically you need to do the difference between the rate in and the rate out here. I'm having trouble working my thing. Here we go. So that means rate in, they want to know R of 3, subtract out the rate out, which is D of 3. They want to know if it's positive or negative. If it's positive, the amount of water is increasing. If it's negative, the amount of water is decreasing. So we already have R in our calculator. We're now going to put D into our calculator. So negative 0.04 t cubed plus 0.4 t squared plus 0.96 t, enter. Okay, so now let's go ahead and evaluate. We'll first evaluate R such that t equals 3. And then we will evaluate D at t equals 3. And then we are going to subtract. So we have rate in minus rate out. And we get negative 0.313. So since this is, oops, it didn't need another equal sign, negative 0.313, since that is less than 0, the amount of water in the drain pipe is decreasing at time equals 3. Since basically R of 3 minus D of 3 is negative. Okay, part C, this is the one that's going to take all of our time. So I'm going to go ahead and add another page, and we'll go ahead and copy this problem to the next page so that I have lots of space to work on part C. Part C says, at what time on the closed interval from 0 to 8 is the amount of water in a pipe at a minimum? I strongly recommend creating a table of values. You know you need your endpoints, 0 and 8, and then this is going to be the amount of water right here. We know at time 0 we have 30 cubic feet of water. And then what we need to know is we need to know the critical point of our water function, of the amount of water function. The critical point is going to come where R of t minus D of t equals 0. So I need to deal with that on my calculator. So I'm going to use the solve function, F2, and I'm going to grab my original rate function. I hope this works the way I want it to, but original rate function equal to the original rate out function, because that's effectively saying if the rate in versus the rate out are equal to each other, then I am going to have no change in the amount of water in the drain pipe. I have a 0 of the rate function. And the reason why I commented that I don't know if this is going to work is because on the TI-89, if you're trying the solve function with a sinusoidal curve, you could have a problem getting infinite solutions. So I don't know if this is going to work. And it says busy for a long time, so I'm actually going to abandon that. And I'm going to go to my graph, which is always a good idea if you're trying to solve a sinusoidal function. So what I'm going to do instead is put the sine function on my calculator, 20 times sine of, and I have to use x, beware, you can't put t in on the graphing screen. And then you have negative 0.04x cubed plus 0.4x squared plus 0.96x. So there are my functions. My window, I need to make sure I'm covering 0 to 8 on the x-axis, and on the y-axis, I know I have at least 30 cubic feet of water, so I'll go up to 50 on the y-axis, not knowing what I need. So there's my rate in. Here's my rate out. Looks like I went too high on my y-axis, so it's actually kind of hard to see. So I'm going to change that again and bring it back down to, say, 25. See if I get a better look at this intersection point. And I think I will. And I want a better look just to make sure there's only one intersection point, which I think is true. Okay, good. One intersection point, so let's find it. F5, intersect, first curve, second curve. Now let's go left bound it, enter, right bound it, enter. And I find out that the critical point is at 3.2716. So I'm going to write down as much of that as I can. 3.2716, and the next two numbers were 5 and 8. So now I have a table of 3 values. So effectively, the value that goes in at 3.271 is going to be my initial value plus the integral from 0 to 3.271, etc., of rate in minus rate out. And then at time 8, I'm going to have the initial value of 30 plus the integral from 0 to 8 of rate in minus rate out. So now I've got to go to my calculator, back to the home screen, and I've got to take 30 and add to it the integral of rate in minus rate out. And I believe I already have set up in here the integral of just rate in. So I'm going to use that and change it up. So I had rate in, let's subtract out rate out, and I'm subtracting out then the negative 0.04 t cubed plus 0.4 t squared plus 0.96 t. So there's my rate in minus rate out, and my limits of integration for this first one are going to be 0 to 3.27165.8, and I'm using as many decimal places as I can just to get the most accurate number possible. And I get 27.9645. So let me write that down here. 27.9645. Okay, so right away, that's smaller than my initial value here of 30. So now let's find out what's happened at time equals 8. All I have to do is change my integral to end at 8. And when I evaluate that in my calculator, it's busy. Okay, I end up getting 48.544. And that is bigger, and I wanted, of course, the minimum amount of water. So at the question was, at what time do you have the minimum amount of water? So the answer to that question is at time equals 3.271, and your justification is this entire table of values. Okay, and the fourth part of the problem says the pipe can hold 50 cubic feet of water before overflowing. For time greater than 8, water continues to flow into the pipe until the pipe overflows. Write but do not solve an equation involving one or more integrals that gives the time when the water starts to overflow. So we already have a pretty good idea of how this is going to look because of the work we've just done. We know that we have 30 to start, and that if we integrate from 0 to some time, which they want us to call W, of rate in minus rate out, we will eventually get to 50. So that is your expression, and you'd have to solve it for W.